In this video, we will cover the last two assumptions of CLRM. The sixth assumption says that the number of observations n must be greater than the number of parameters to be estimated. For simple linear regression, y is equal to beta 0 plus beta 1 into x plus ui. There are two parameters, beta 0 and beta 1. So we need at least more than two observations. Regression analysis estimates unknown parameters using the available sample data. If the number of observations is less than or equal to the number of parameters, there is insufficient information to obtain unique and reliable estimates. Therefore, the sample size must be larger than the number of parameters being estimated. This assumption is important because it ensures that there is enough information in the data to estimate all parameters uniquely. If there are too few observations, the regression coefficients cannot be estimated properly, making the regression analysis impossible. The seventh assumption of CLRM is that the values of the explanatory variable x must not be same. In other words, variance of x should be greater than 0, meaning the x variable must show variation. Regression tries to measure how changes in x affect y. If all observations have same value of x, there is no variation in the explanatory variable and therefore no basis for studying its effect on y. Since the slope coefficient is calculated using the variation in x, it becomes impossible to estimate the regression line when all x values are identical. This assumption is necessary because regression analysis relies on variation in x to estimate the relationship between x and y. Without the variation in x, the slope coefficient cannot be calculated and the effect of x on y cannot be measured. This covers all the assumptions of classical linear regression model. Follow for upcoming videos.